All right, so chapter 18, section 2, we're going to be looking at continuing our conversation with classification. One of the things we look at a lot now is something called phylogeny. And phylogeny is the evolutionary relationship between organisms. If an organism came from another set of organisms, that would be phylogeny. That would be important for phylogeny. So, for example, organism D came from the same common ancestor as C, B, and A. And then what we're actually going to do here in this chart is we would look at that D is most related to C. The common ancestor of D and C is right here. The common ancestor for D and B is right here. The common ancestor for D and A is here. And you can also go as far back as B. Where does B and A match? Oh, it matches back here. The lines here are showing evolutionary structures that have developed over time. So sometimes they'll be like feathers, 2 legs, the ability to fly, right? If they're talking about a group of birds, that would be a good way for them to go about looking at these sort of things, is looking at the structures you would need in order to get those things to go. And that would be something that they would look at. This particular type of phylogenetic tree that has to do with structures is called a cladogram. Now, you're not going to see that word, I don't think, anywhere in here, but a cladogram is specific for the phylogenetic tree that shows structures and how structures came about. And a cladogram looks at cladistics, which is a method of making evolutionary trees. And it's based on common ancestry, and it does so, again, based on structures. The structures and how they come about is the basis for cladograms. Okay, so a clade is a group of species that shares one common ancestor, over here, all of its descendants, and the structures that come about therein. Each species in a clade shares some traits with the ancestor. So there's something that the ancestor has that all of these have. And then each species has a unique structure, a unique thing about them, a unique trait. So let's say all of these are plants. They're all photosynthesizers. That might have been the shared. And the unique might have very well have been at each step is a different level of unique structure that lets them do something special. So again, here are everything in this cladogram has 4 limbs with digits. So that means it's got 4 legs with toes of some kind, right? And as you go up this chain, each and every step will give you a new unique character. So embryo protected by amniotic fluid, that's new to these guys. Okay, amniota clad. A skull opening behind the eye, that's unique to them. But they also have embryo protected by amniotic fluid. And they also have 4 limbs with digits. And if you look at the skull opening in front of the eye and jaw, right? These guys have all of these things as well. So each step along this way, you keep all the stuff before it and you add something new, and then you have some break off organisms that move on from there. And it's just a different way of seeing how organisms are related and how these related organisms, where they are compared to each other and what came first, right? Which structures came around first, which structure came around second, and who's got those structures. A node is a branch point, which is what we were pointing out before. It's literally where one line meets another. So the amniota clade, the common ancestor is here at this node. Okay, that node literally will tell you that that particular clade happens to have a common ancestor there. So a clade can be identified by snipping a branch under a node. So if I take this clade and I take this branch off, right, and I include the node, right, the common ancestor, I will get an entire group of organisms that all share common characteristics that are listed there. So if I were to take let's say the diapsid clade here, then I would snip it here. I would get all this out, and I'd get a bunch of organisms with opening in the side of the skull openings behind the eye, embryo protected by amniotic fluid, and 4 limbs with digits. I would get all those things because their node is just past this clade. Once you're able to do DNA and some molecular analysis, you can get a better understanding of relative relatedness. Now, this is relatively new. This is not something that's been around for hundreds of years. This is relatively new, and it gets cheaper every day, so we're able to do it without the need to worry about money. And once we've done it, you can see how you can go from all of these guys having a common ancestor because all of these things look similar to no, these look similar and these look similar, but these two are different. And it changes things. And the more, it's not even the fact that it changes, the more accurate you are, the closer you are to the reality of the situation, the easier it is to study new organisms. And that is it for chapter 18, section 2.